All right. Okay, so yesterday we so this section, this lesson is about the second derivative test. Right? Second derivative test functions a lot like the first derivative test. Two differences. Instead of the first derivative, we're dealing with the second derivative. That's the first difference. The second difference is it doesn't talk about increasing or decreasing. It talks about concavity. Okay, if something's concave up or concave down. So if the if the second derivative is positive, it's concave up. Okay. If the second derivative is negative, it's concave down. If the second derivative is equal to 0, it's what we call an inflection point. It's a change in concavity, right? Those are inflection points. That's where we change from concave up to concave down or vice versa. Okay? So it functions a lot like the first derivative test. The only difference is we use the second derivative to do all of this. Okay? That's why it's called the second derivative test. So there's some examples, and then we did a couple examples here. So that leaves us to number, let's see, what is that? So this one kind of gives you pictures. I skipped over this yesterday. This kind of gives you pictures to what it looks like. So when we say increasing in concave up or decreasing in concave down, it's kind of idea what it looks like. So yesterday we did number 3 where it was decreasing in concave up. So that one would look something like this over here. That's how the graph would look from, where did we find, from 5 to 9. From 5 to 9, that's what it would look like. So it kind of gives you, that's what the table is for. What does it kind of look like? What's one example of it? Okay. Okay, so let's look at number 4. Number 4. Okay, so number 4 is very similar to the one we did on number 3. It just asks us some different information. So this one says, given f of x, determine all intervals where it's both decreasing and concave down. So both. Okay, where does it overlap? Where is it decreasing and concave down? Okay, so decreasing, first derivative. Concave down, second derivative. Okay, so decreasing means first derivative is less than 0. Concave down means second derivative is also less than 0. So we're looking for where both of those things are true. Okay, so the first thing we're going to do, find the first derivative. Find out where it's decreasing. So 24x to the third minus 72x. First derivative. Set it equal to 0. Okay. Well, it's a binomial. It's got two terms, 24x to the third and negative 72x. So it's got a GCF. Both of them can be divided by 24x. So that's going to leave x squared minus 3, I believe. Okay. Set both of those guys equal to 0. We're going to get our answers. So 24x equals 0. X squared minus 3 equals 0. So with 24x, I'm just going to divide by 24. I get 0. 0 is one critical value. The other one, I have to add 3 to both sides. And then take the square root. So the square root of 3 is not a nice, pretty number. So I'm just going to leave it the square root of 3. The only difference is it's going to be positive and negative square root of 3. There's going to be a positive and a negative. Anytime we take a square root and we're solving, we always have to have a positive and a negative. Okay, so those are all our critical values. We got 3 of them. So the next thing I'm going to do is I'm going to draw a number line with all of those guys on it. Negative root 3, 0, positive root 3. This will tell me where it's increasing and decreasing. This is review. We've done this before. We've done the decreasing, increasing part last week. Okay. But I need to figure out where it's decreasing. Okay, so I need to pick a number less than the square root of 3. The square root of 3 is like 1.7 something. So this guy here is negative 1.7 something. This is positive 1.7 something. Okay. So over here, pick negative 2. In here, negative 1. Oops, a little delayed. Oops, it's lagging a little bit. Let's see. Oh, there we go. So over here, negative 2. We'll try negative 2. Over here, we'll try negative 1. For this guy, we can choose positive 1. And for this guy, we can choose positive 2. Okay? So first thing I'm going to do is check out negative 2 to the first derivative. We want to plug it into the first derivative. I don't care what number, I just want to know sign, positive or negative. Okay, so 24 negative 2 cubed minus 72 times negative 2. So negative 2 cubed is negative 8. So 24 times negative 8. And then these two guys are going to make 144 when I multiply them together. Because negative times a negative. So when I multiply these two guys, I'm going to get negative 7, no, negative 8, negative 182? No, negative 192. That's going to be a negative number. That's decreasing. Okay, now I'm going to plug in negative 1. Negative 1 cubed, still negative 1. Times 24 is negative 24. And then this guy will be positive 72. That's going to be a positive answer because you'll end up with a positive number. Okay. So now between 0 and 1.7, I'm going to choose positive 1. 24 times positive 1 cubed minus 72 times positive 1. So it's just going to be 24 minus 72, which is a negative number. And then the last one is positive 2. 24 times positive 2 cubed minus 72 times positive 2. So it's going to be similar to what we got above. So it's going to be positive 192 instead of negative 192. And then this guy is going to be negative 144. Similar numbers that we got earlier, just positives, different signs. So it's going to be positive. Okay. So we are decreasing. Here and here. Before the square root of negative 3 and between 0 and the square root of 3. Okay, that's where we're decreasing. Now we're going to have to do the second derivative test. That was the first derivative test for increasing, decreasing. Second derivative test is to tell me whether it's concave up or concave down. Okay, so let me get some more room here. Example 4. Example 4 continued. Okay. So the first thing I got to do is find the second derivative. Well, first derivative is right there. So 3 times 24 is going to be 72 minus 72. So 72x squared minus 72. That's the second derivative. Okay. So I'm going to do the exact same thing. Exact same thing I just did. But now with this guy. Okay, set it equal to 0. GCF 72. I get x squared minus 1. Okay. X squared minus 1 is difference of squares. You can change it if you want. When you're solving, it doesn't really matter because you're going to get the same answer. But if you were factoring that, yeah, it is difference of squares. This is x plus 1, x minus 1. So when you're factoring, definitely important. When you're solving, not as important because you're just going to set them all equal to 0. Okay. So set all the factor terms equal to 0. $72 has no variable, so I can't solve for x, and it's not equal to 0. So it's not going to give me an answer. Okay, so the other two, subtract 1 from both sides, add 1 to both sides. So I get two answers. -1 and +1. Those are critical values, but for second derivatives. Remember, these are called inflection points. This is where you change concavity. Change from concave up to concave down, or from concave down to concave up. We're going to do the same thing. Draw a number line. -1, +1. So I need to choose 3 numbers. 1 less than -1, 1 in between -1 and 1, and 1 greater than +1. Okay, so I'll choose -2. I'm going to plug that into the second derivative. Again, all I care about if it's positive or negative number when you're doing this. You don't have to actually finish like, oh, I don't have a calculator. You don't need one because you're just trying to see, will I have a positive or negative number? Okay. So we do exponents first. So it'll be positive 4. So 72 times positive 4 minus 72. Well, if I go 72 times 4, that's going to be 300 and something, or 200 and something, almost 300. Minus 72 is going to give you a positive number. Means that's where it's concave up. Okay. In between negative 1 and positive 1, 0. So 72 times 0 squared minus 72. 0 squared is 0. Times 72 is 0. So you're just going to get negative 72. And then the last one, positive 2. You're going to get the same answer that you got for negative 2 because you square it. Okay, I'll stop there for a little bit. Okay. So we know it's concave up less than negative 1. So from negative infinity to negative 1, it's concave up. Concave down in between negative 1 and positive 1. And then concave up after 1. So let's go back to the question. The question said, where is it decreasing in concave down? Okay, well, let's go look where concave down is. Concave down is right here. Okay. So now what we got to do is see where they share. It's kind of hard to see if I can. Where do they share territory? Where do they share territory? It looks like 0 to 1. Yeah, it looks like 0 to 1 is where they share territory. Because decreasing would be negative square root of 3, which is kind of over here and this way. That's not double shade. 0 to the square root of 3 is where I shaded above. So it looks like the double shade is from 0 to 1. So we say f of x is both decreasing and concave up or down. What am I looking at? Concave down. From 0 to 1. Okay. Like I said, those questions, you'll most likely see one of those questions on a multiple choice or a free response because those questions are popular because it's 2 for 1. They can have you have to know how to use the first derivative test and the second derivative test, and then you have to know how to combine them. Okay, so that's why I put 2 of these questions on the notes because they're very popular on tests and quizzes and stuff like that. Okay. So let's look at example number 5. So we need to find all intervals on which f of x is increasing. So this one is just increasing. So how do we check to see if something's increasing or decreasing? Not continuity. What do we have for increasing, decreasing? What do we have to do? Check. What do we use? First derivative test. Yeah. Okay. Yeah, for mean value theorem, we would check continuity. We're not doing mean value theorem, so we're not really worried about continuity on this one. We just want to know where is it increasing, where is it decreasing. Okay. Okay, so first derivative test. So do this one with me. I'm not doing it for you. I'm doing it with you guys. So act like this is your problem that you're doing. If you get stuck, then you can look up here, but try it on your own. Okay, especially when we're doing first derivative, because we've done that for 2 chapters now. Okay, we've been finding derivatives for a while. Okay, so I'll do it up here, but I want you guys to kind of do it on your own, see if we get the same answer. Okay, so to find derivative of x, I have to use the quotient rule. Okay, so low times the derivative of the high. Okay, I'm going to use the power rule. Negative 8x plus 3 minus the opposite. The high times the derivative of the low. So everyone always freaks out, or not everyone, I shouldn't say everyone, but a lot of people freak out. Come on in. Oh, thank you. When they see a derivative for e of x, e to the negative x, or e to x. How do we find derivative? But it's not really that bad. How do we find derivative of anything e related? What's the first thing it's always going to do? Rewrite itself, repeat it. So whatever it is, e to the negative 2x. And then what do we always tag on? The derivative of the exponent, negative 2. Done. Okay. Thank you. All right. Over the bottom squared. Okay. So eventually, I'm going to need to set that equal to 0, right? The top equal to 0 and the bottom equal to 0, right? I'm going to do that right now. I'm not going to clean it up yet, because I can clean it up, but I'm not going to do that yet. So I'm going to set up 2 different things. 0 equal to the top. And this is negative 2 e to the negative 2x. Okay, there's that one. And then the bottom. So when I have a power to a power, like I do on the bottom, a power to a power, what's the rules if you have a power to a power? What do I do with the powers? You actually multiply them. Yeah, that's when you multiply them. If you have a power to a power, you multiply the power. So it's going to be e to the negative 4x. So this is going to give me my critical values because I'm setting them equal to 0, right? I'm going to focus on the right one. I'm going to focus on the one to the right. How do I solve this guy? So this guy right here. This guy, yeah, to the right. Let's look at this guy first, because this guy looks smaller. It is smaller, right? So to get the power down to the ground, I have to change it from an exponent to a log. But don't even worry about that. What this question is asking is, what value would you plug in here to make the whole thing 0? what number would I have to plug in here to make the whole thing 0? So if I plug in 0, that would be this, right? Which is e to the 0. So is e to the 0 equal to 0? No, it's actually equal to 1, right? So not 0. It's kind of a trick question. What value would I plug in here to make this whole thing equal to 0? Well, think of a regular. Let me give you an easy one. Let's look at a number like 2. Regular 2. What power would I have to give to make it 0? The only thing I can do is give it a power. So any power you want. What power would I give it to make it equal 0? Positive, negative, decimal fraction, whole number, it doesn't matter. Whatever you want to do. What power would I have to give it to make it 0? So if I gave it 1/2, what would that mean? 2 to the 1/2, right? It means the square root of 2. That's what that means, right? Is that equal to 0? No. That's the trick part. There is no power. I can't make a number 0 only giving it a power. The only way to make it 0 is to take it away, subtraction, or to multiply it times 0. Not power. There's no power. There is no power that exists that I can give it that would make it 0. So this answer, there is no answer. These two will never equal each other. Those two guys will never equal each other because there is no number I can plug in there that will make it 0. So that guy, I don't even have to worry about because it's never going to give me a 0 answer. It's always going to be, it might be negative, might be positive, but it'll never give me something that's 0. Okay, so now let's focus on this guy here. So this guy, some of you guys are like, distributive property. Sure, let's do that. Distributive property. Okay, and then in here, I got to do distributive property over here. So I'm going to get negative 8x, times e to the negative 2x plus 3 times e to the negative 2x when I distribute. And then I got to distribute on the inside of the brackets. So I'm going to multiply times negative 2. I get 8x squared times e to the negative 2x. And then negative 2 times positive 3 is negative 6x times e to the negative 2x. Still in brackets. So I got to distribute the negative now. Distribute. So now it won't have any parentheses or brackets. It's got 4 terms. 4 terms. Okay. Do you notice anything about all 4 terms? They all have e to the negative 2x. I can factor that out. So when you factor it out, it goes away. So now I have negative 8x plus 3 minus 8x squared plus 6x. On the inside, I can combine some like terms. I can combine negative 8x and positive 6x. I'm going to rearrange some stuff too. I got negative 8x squared minus 2x plus 3. Okay. So now I have one big term. They're both being multiplied together. I have this guy on the outside and then my parentheses. They're both being multiplied together to make 0. So that means I can set them both equal to 0. Okay. So I'm going to set this guy equal to 0 and set this guy equal to 0. Oops. Well, the guy on the left, that looks like a guy we just saw, right? What did we say about that guy? That we couldn't find an answer, right? So the same thing with this guy. So it's asking the same question. What power could I give it to make it 0? There is no power. So now let's focus on this guy. This guy's a trinomial. So I'm going to factor it using the trinomial steps I always use. Okay. The first thing I'm going to do, though, is divide them everything by -1 because I like to have the first term positive. Okay. Okay, so now I got to factor this guy. So let's see. Got to come up with the two numbers that multiply to be 24 and add to be positive 2. Negative 24, right? 6 and negative 4, right? Because you multiply 8 times negative 3. Okay, let's see. 8x squared minus 3, 6x minus 4x. It's going to be 4x and 2x plus 3 minus 1. 4x plus 3, 2x minus 1 with a negative 1 in front. Set them all equal to 0. So you get 4x plus 3 equals 0. 2x minus 1 equals 0. I'm not going to set negative 1 equal to 0. That's not going to give me an answer. Subtract 3 from both sides. Divide by 4. I get negative 3/4. And then the other one, I'm going to add 1. Divide by 2. I get 1/2. Okay. Those are my two critical values. Oops. So my last step is to check to see where it's increasing and decreasing. I have two critical values, negative 3/4, positive 1/2. Okay, so I'm going to move over here now. Negative 3/4, positive 1/2. Okay. So I'm going to pick a number less than -3/4, -1, -2, -3. I could pick a number in between -3/4 and 1/2, 0. Pick a number bigger than 1/2, 1, 2, 3. Pick an easy number. So I'm going to pick -1 first because the derivative is kind of ugly. So I have a whole bunch of stuff over here. Whole bunch of stuff over here. It's all the derivative. So pick the one that's most appealing. Like the top one up here, I wouldn't want to plug anything into here because that's got a lot of different stuff in it, right? Because you got to plug in an x here, 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 and here. That one I really don't want to plug it into. The one I think that's most appealing is probably this guy down here. It's the same thing. It's the same thing. It's just a lot less places to plug in. This was the top. That was the bottom. Okay, so I'm going to plug in -1 there. E to the -2 times -1. -8, -1 squared. -2 times -1 plus 3. And then the bottom is e to the -4 times -1. All I care about is a positive or negative answer. I don't care what the actual number is. Okay, so once you know if it's going to be a positive or negative, that's it. Okay. So let's see. Let's try to do mental math. This is going to be e squared. Okay. This is going to be +1. It's probably easier just to do it. Let's see. -8 times 1 is -8, plus 2 plus 3. And then this would be e to the 4th power. So I'm going to get e squared -3 over e to the 4th. -3, e squared is positive. E to the 4th is positive. But -3 times those things is going to give me a negative answer. So that's negative. Let me move this stuff down so I can... Oops. There we go. Okay. So now let me do it with 0. E to the -2 times 0. -8 times 0 squared minus 2 times 0 plus 3 over e to the -4 times 0. E to the 0, which is 1, times 3 over e to the 0. Because these guys in here would cancel out. Positive. Now I have to plug in a number bigger, so +1. One more. e to the negative 2. That number is still positive. E to the negative 2 is positive. It's just a small number. Negative 8 minus 2 plus 3 over e, oops, this should be 1, to the negative 4 power. E to the negative 4 power is still positive. It's a small number, but it's still positive. So we're going to get e to the negative 2 times negative 7 over e to the negative 4. The only negative there is negative 7. The only thing that would cause a negative, e to the negative 2 is not a negative number. E to the negative 4 is not a negative number. Okay, so that's going to be negative. All right. So they want to know where it's increasing. F of x is increasing from negative 3/4 to 1/2. Okay. All right. All right. Okay. So there's 2 more. I think we're just going to do 1 more, and then we'll be done. So I think the last one is kind of a, you have to find the critical values. You have to find increasing, decreasing, concave up, concave down, relative maximum, minimum, inflection points, vertical asymptotes if they exist. That one is kind of like a everything in one question. I don't think we need to do that in the notes because you guys have done stuff like that. The last one we're going to do is number 6. So this is what we're going to do. So we'll start number 6 today. We probably won't finish it. And then tomorrow I'll give you the assignment for this. So the practice assignment, and I'll let you guys work on that in class, during class. So tomorrow, that's all we'll do. Okay. And then Thursday, we'll start the next lesson. Friday, we don't have school. So Friday, when we won't be here, we'll just continue next week. Okay. Okay. All right. Last question. Last question for these sets of notes. So it says, use the second derivative to find relative extrema. What's the problem, or what's the issue there? Not issue, but what's the kind of the weird part there in that question? We usually use the first derivative to find relative extrema. Continue to use the first derivative to find relative extrema. Here's the thing. Can you use the second derivative to find relative maximums and relative minimums? Yeah, there is a way. But why complicate yourself? You already know how to do it using the first derivative. Okay? You're going to see this type of question on a multiple choice. And on multiple choice, they don't care how you find the answer, right? This type of question is never on a free response. So you don't have to worry about doing their way, okay? I don't teach how to find the second derivative to use to find maximum minimum. There is a way, but why it's not needed. It's not necessary. So do what you've been doing to find relative extrema. First derivative. Okay? So let's do that. First derivative. So how are we going to find the first derivative for f of x? What are we going to use to find first derivative? Product rule. Yep, product rule. So we're going to use the product rule because it's sine of x times cosine of x. So product rule says the first times the derivative of the second. The derivative of cosine is negative sine plus the opposite, the derivative of the first, which is cosine, times the second, cosine. So essentially what you see is negative sine squared of x plus cosine squared of x. They're each squared. Okay. After we find the first derivative, we always set it equal to 0. So how do you solve sine or trig, sine, cosine, tangent? How do you solve this? Well, you solve it kind of a different way. You can't isolate. We can't get x by itself because x is an angle. We can't get it by itself. There's no way. So this is what I usually do. I set them equal to each other. So I'm going to set this guy equal to each other. So I get positive sine squared of x equals cosine squared of x. Take the square root of both sides. The square root of sine squared is just sine. The square root of cosine squared is just cosine. That's about as far as we can solve it. I can't get x's by itself. It just doesn't work that way. So what I need to find is where within this interval are sine and cosine exactly the same? Where are sine and cosine exactly the same within this interval? So I go to my tables. I go to my tables. What I want to find is where are sine and cosine exactly the same at exactly the same time? Let's see. Here and here, right? Where else? 5 pi over 4. And I believe that's it. Yep, that's it, right? Okay. Where is our interval, though? Yeah, this is our interval. Negative pi over 2 to positive pi over 2. Uh-oh. I only have positives on here. Where are the negatives? They're actually on here. Where are the negatives? So if I want negative pi over 2, where is that? Direction, right? So this is where I'm asking for. This is where the interval is from here to here. Those values, where the blue is, are where the interval is. Because if I go this way, it's positive square root of positive pi over 2, right? But if I go this way, it's the same distance, but it's just in the negative direction. So where in those values? Well, we said pi over, what was the first one? Pi over 4. So definitely pi over 4. So let me write that down. Definitely pi over 4. But then we also said where? 5 pi over 4. Is 5 pi over 4 in the blue stuff? No, so we don't care about that one. What's that? 7 pi over 4, they have the same thing? They close, different sides, yeah. So yep, that's what we care about. So the only one we care about is pi over 4. Okay. So I need to plug in a value that's less than pi over 4 and greater than pi over 4. That's within the interval. Okay, so less than pi over 4, I think 0 is probably the best one. 0 to use less than pi over 4. Bigger than pi over 4, you have, you can use, we can't go over pi over 2 though. So I can pick pi over 2 because that's inside the interval. I can pick a pi over 3. So the only two ones I can pick for greater than pi over 2 is pi over 3 or pi over 2. Either one works. I'll choose pi over 3. Okay. So we're running low on time. That's where I'll stop. So when we come back, that's what I'm going to do. I'm going to figure out if it's positive or negative, see where it's increasing or decreasing. Okay. And that'll be it. And then I'll give you your assignment tomorrow and you can work on that. You can ask questions, anything you need.